Another example, let f of x be the big parentheses 1 plus 2 sine of x to power 1 over x. Evaluate the limits of f of x as x approaches 0 from the right side. One thing, let's find the form. What is the form of this? If I was going to plug this 0 in here, I would get 1 to power infinity. So form is 1 to infinity, which is an indeterminate form. We learned that when it's a function, non-constant function, to power a non-constant function, the best way to evaluate limits is to use the L'Hopital rule. To go about doing that, first thing is to rewrite the function and to write the limit in this format. Exponential of natural log of the function. This exponential to power natural log, e to power ln, they're inverse functions, and so it's actually not changing the limit at all. So the next step is, normally we don't like writing e and then to power and then another power. To basically, just for the beauty reasons, we want to bring that and write that e as an exponential function. So this is how we present it. Exponential, and it's going to be a lot less messy. And many times the calculation mistakes that happens with the going to power, that gets eliminated by rewriting it as exponential. Exponential is a continuous function, so I can bring the limit inside of it. So exponential limit x goes to 0 from positive side of ln of 1 plus 2 sine of x to power 1 over x. This parenthesis closed here and that one over there. Next, the reason that we wrote as e to power ln was that e to power natural log is that I can use my logarithmic laws to bring down the exponent, and so that's what I'm going to do. And 1 over x times ln of 1 plus 2 sine of x. The next step is now I ended up with, if I plug in 0 in here, the form has become infinity times ln of 1, which is 0. Using L'Hopital rule requires me using reformatting this into a 0 over 0 or infinity over infinity. This one is somewhat obvious. X is in the denominator anyway. This goes to 0, this goes to 0, so let's put them as a quotient. Now it's time. Now the form is 0 over 0, and it's time to actually use the L'Hopital rule. Again, L'Hopital rule is not the quotient rule. Quotient rule is for taking derivative. L'Hopital rule takes the derivative of the numerator and divided by derivative of denominator and creates another limit for us. So L'Hopital rule. And that would be exponential stays. Limit at x approaches 0 from positive. Derivative of natural log of 1 plus 2 sine of x is going to be 1, derivative of inside divided by inside. Derivative of inside is 2 cosine of x divided by inside. And then derivative of x, which is 1. Now, let's check to see if this is actually a limit of a form that I can evaluate. If I plug in 0 in the numerator, cosine of 0 is 1, so I get a 2 in here. If I plug in 0 in the denominator, I get 1 plus 2 times 0, which is 1, and over 1. So I actually can evaluate this by plugging in. So the answer is exponential. Plug it in, and then the limit goes away. 2 divided by 1. That is, the answer is e to the power 2. And that's our final answer for this limit.